Okay, let's go ahead and look at that same beam in bearing. Let's assume that this beam is held by a beam here and a beam here at the end. We'll assume it's right at the end, and let's say it's a beam that's 50 mil wide. Okay, 50 millimeters wide. So because it's both sides, it's going to be symmetrical, so we only have to do this problem once. So let's have a look at bearing. The formula for bearing, if we have a look at our sheet here, bearing capacity is an N because it's just a straight force in newtons, and it equals phi times K1, K4, K6, K7, F-P, and AP. Alright, so we'll go through each of those. Phi is exactly the same as it was before, it's 0.9. And so that comes from table 2.1. K1 is also the same, it's the same K value as for before. So what do we have for that? I think we had 0.94. Now in the reference here, I could either write page 3 or I could go back to the table reference. I'm just going to write page 3 because any discussion about it I've had back here. K4 equals 1. K6 equals 1, and that's also page 3, page 3. K7 is a new one. And for K7, we go to table 2.6. The bearing length, the bearing factor. That's a factor about how wide is bearing. Is it a knife edge it's on, or is it something quite wide? So the length of the bearing member, is that, I was talking about the 50 mil bearing, there it is there. Oops. Now you only get to use this if your piece is not right at the end. If it's actually in a little bit, it's got to be in at least 75 mil. So if it was in 75 mil, I could use a value of 1.2, except because I've said it's right at the ends, I don't get to do anything, so K7 equals 1.0. FP is from table H2.